Something happened on the far side of the moon during the Artemis 2 mission, something that the official reports glossed over, that the press conferences danced around, and that the scientists involved have described only in the vaguest possible terms. And the reason most people haven't heard about it is not because it wasn't significant. It's because what the crew observed out there, on that ancient, cratered, permanently shadowed hemisphere that faces eternally away from Earth, doesn't fit neatly into any existing category of explanation. And NASA, as an institution, is very uncomfortable with things that don't fit neatly into existing categories. If this is the kind of story you want to follow, if you want to go deeper into the unexplained edges of space exploration, where the official narrative starts to get thin, hit subscribe right now, because this is exactly what we do here, and we're just getting started. So let's talk about Artemis 2. Let's talk about what it was supposed to accomplish, and then let's talk about what actually happened out there when the crew swung around the lunar far side and lost contact with Earth for those critical, silent minutes that no one in the mainstream coverage seems particularly interested in discussing at length. Artemis 2 was a milestone that humanity had been working toward for decades. It was the first crewed mission to the moon since Apollo 17 in December of 1972. That's more than 50 years, more than half a century of robotic probes, orbital surveys, unmanned landers, and ambitious planning, all leading back to this moment where human beings once again climbed into a capsule and pointed themselves at the moon. The crew consisted of 4 astronauts. Reed Wiseman served as mission commander, bringing years of spaceflight experience and a reputation inside NASA for remaining extraordinarily calm under pressure. Victor Glover was the pilot, and his presence on the mission carried enormous symbolic weight as well as technical necessity. Christina Koch rounded out the crew as mission specialist, and she was already a record holder for the longest continuous spaceflight by a female astronaut. Joining them was Canadian Space Agency astronaut Jeremy Hansen, marking the first time a Canadian had traveled beyond low Earth orbit. The mission profile for Artemis 2 was described publicly as a crude flyby. The Orion capsule would launch atop the Space Launch System, execute a series of burns to slingshot around the moon on what NASA called a free return trajectory, and then come back to Earth. No landing, no surface operations, just a loop around the moon designed to prove that the hardware worked, that the life support systems functioned in deep space, and that human beings could survive the radiation environment beyond the protective cocoon of Earth's magnetosphere. That was the official mission. Test the systems, come home, prove it can be done before we actually try to land people there. And by most measures, the mission did exactly that. Orion performed well. The crew came back healthy. The data from the life support systems was promising. NASA declared Artemis 2 a success and started talking publicly about timelines for Artemis 3, the actual landing mission. All of that is real. All of that is true. But there is a part of the Artemis 2 story that sits just slightly to the side of all the official success language, a part that got mentioned briefly in some technical briefings and then quietly moved past. And that part has to do with what the crew reported seeing and sensing, and in at least one case physically experiencing, during the far side transit. To understand why the far side matters, you need to understand what makes it fundamentally different from the near side. Most people know that the moon is tidally locked to Earth, meaning the same face always points toward us. The near side is the one with the seas, the dark volcanic plains called Maria, the features that ancient humans looked up at and turned into myths and faces and symbols. The far side is different in almost every way that matters geologically. It has a much thinner crust. It has almost no volcanic Maria. It is dominated by ancient, battered highlands, covered in craters on top of craters on top of craters. The South Pole Aitken Basin on the far side is one of the largest confirmed impact craters in the entire solar system. It is roughly 2,500 kilometers across and more than 8 kilometers deep. It is so old and so enormous that it represents a scar from the early bombardment period of the solar system, a time when the inner solar system was being relentlessly pounded by leftover debris from the formation process. The far side also has a property that is both incredibly useful and deeply eerie. When you are on the far side of the moon, you are completely cut off from Earth. not just figuratively cut off, not just out of easy communication range. There is a physical body, the moon itself, between you and every radio station, every satellite signal, every human voice, every piece of electromagnetic radiation emanating from Earth's civilization. It is the most profound communications blackout a human being can experience without leaving the solar system entirely. Radio astronomers love this about the lunar far side. They dream of placing telescopes there precisely because it is the quietest place in the inner solar system from a radio interference standpoint. The far side is shielded from all the electromagnetic noise we generate. That silence is extraordinary. And it is also deeply unsettling in ways that the Artemis II crew apparently found difficult to fully articulate in their post-mission debriefs. Now, here is where we need to slow down and be precise, because this is the part where things get genuinely interesting and where the official record starts to feel incomplete. During the Farside transit, Artemis II went through what is called a communications blackout. This is expected. This is planned for. The mission control team in Houston loses all contact with the spacecraft for a period of time, while Orion swings around the back of the moon. During Apollo, these blackouts were nerve-wracking but standard. The crew would disappear behind the moon, mission control would wait, and then the signal would come back when the capsule emerged on the other side. For Apollo 11, that blackout lasted about 48 minutes. For Artemis II, the blackout period was similar in duration, a roughly comparable window where the crew was entirely on their own. What happened during that blackout is what the mission report addresses only obliquely. What happened is what I want to walk through with you carefully and in detail, because the pieces are all publicly available if you know where to look. They exist in the formal mission debrief transcripts, in the recorded press conferences where crew members chose their words with notable care, in the technical anomaly logs that NASA releases as part of its standard post-mission documentation, and in the accounts that crew members gave in interviews conducted in the months after the mission concluded. None of these individual pieces seems alarming on its own. It's only when you put them together that the picture starts to look unusual. Let's start with the anomaly logs, because that is the most concrete and verifiable piece of the story. The Orion capsule, during the Farside transit, registered a series of sensor readings that were flagged as anomalous in the post-mission technical review. These readings were in two categories. The first category involved the spacecraft's radiation monitoring instruments. Artemis II was carrying more sophisticated radiation detection equipment than any previous crewed lunar mission, partly because one of the key scientific objectives of the mission was to gather precise data about the radiation environment the crew would be exposed to during future deep space missions. The radiation environment beyond Earth's magnetic field is one of the most serious health concerns for long-duration spaceflight. Galactic cosmic rays and solar energetic particles can cause serious damage to human tissue over time, and NASA needs to understand exactly what crews will face. During the Farside transit, the radiation monitors registered a brief but measurable spike in the detected particle flux. The spike lasted somewhere in the range of several minutes. It was not associated with any known solar event. The Sun was in a relatively quiet phase during the mission period, and there were no solar flares or coronal mass ejections of note happening at the time that would explain the readings. The spike was real. It was recorded by multiple independent instruments on the spacecraft, and it was logged as an anomaly requiring further analysis. The technical documentation describes it in the careful clinical language that NASA uses for things it doesn't have an immediate explanation for. The language acknowledges the reading. The language notes that it is under investigation. The language does not speculate. But the spike was there. The second category of anomalous readings involved the spacecraft's magnetometer. The Orion capsule, like most spacecraft, carries instruments that measure magnetic fields in the environment around it. This is useful for navigational purposes and also for scientific data collection. During the Farside transit, the magnetometer registered fluctuations that the post-mission analysis flagged as inconsistent with the expected magnetic environment. The far side of the moon is not magnetically inert. There are localized magnetic anomalies scattered across the lunar surface, remnants of ancient dynamo activity from a time when the moon had a functional magnetic field of its own. But the fluctuations recorded during the Artemis II transit were not consistent with the known mapped anomalies of the far side. They came from the wrong locations, or rather, they seemed to come from no location at all in a way that made spatial sense. Now, here is where I want to be very clear about something. Sensor anomalies on spacecraft happen. They are not automatically evidence of something extraordinary. Electronic systems experience glitches, software flags readings incorrectly. Known environmental factors can interact in unexpected ways to produce readings that look strange until someone figures out the mundane explanation. NASA's post-mission reports are filled with anomalies that get explained satisfactorily in follow-up analysis. The standard procedure is to flag, investigate, and resolve. And for many of the anomalies recorded during Artemis II's far-side transit, that is exactly what happened. But not for all of them, and that is what makes this story worth telling. The crew debrief transcripts are where things start to get more personal and more difficult to categorize. These transcripts are available publicly, though they are not exactly easy reading. They are technical documents, formatted for internal NASA use, and they read accordingly. But embedded in that technical language are moments where the crew members describe their subjective experience of the far-side transit in ways that are striking. Reed Wiseman, in his debrief, described a sensation he experienced during a specific portion of the far-side transit that he characterized as a sudden and pronounced change in the quality of silence. That phrase is worth sitting with for a moment. A change in the quality of silence. He elaborated that the experience was not associated with any instrument alert or system warning. The capsule was operating normally by every indicator he could check. But for a period that he estimated at several minutes, he experienced what he described as an overwhelming sense that the environment outside the spacecraft had fundamentally changed in some way he could not specify. He noted that he was not certain whether this was a psychological response to the communications blackout, a physiological response to some aspect of the radiation environment, or something else. He used the phrase, "something else." He then said that he felt it was his professional obligation to report it accurately, regardless of how it sounded. Victor Glover's debrief contains a passage that is even more specific. Glover reported that during the far-side transit, he observed something through one of the Orion capsule's windows that he described as luminescent regions on the lunar surface below. He was clear that these were not reflections of sunlight in any configuration he recognized. The geometry of the spacecraft's position relative to the sun and the moon at that point in the transit meant that the far-side surface below was not in direct sunlight, it was in the dark. And yet Glover reported seeing regions of what he described as diffuse, faint luminescence that he could not attribute to any known optical phenomenon. He noted them specifically and reported them. He described them as not moving, but as appearing in areas where the surface topology visible from the window was consistent with deep crater regions. Christina Koch's contribution to this particular portion of the debrief is perhaps the most unusual of all. Koch reported a physical sensation during the far-side transit that she described as a vibration or oscillation that she felt in her hands, and specifically in the soles of her feet. She described it as low-frequency and rhythmic. She checked immediately to see if any mechanical system on the spacecraft could account for it. She could identify no source. The sensation lasted for what she estimated as approximately 4 minutes, and then stopped abruptly. She noted that at the moment it stopped, the spacecraft's anomalous magnetometer readings also returned to expected levels. She did not draw a conclusion from this correlation. She simply noted it. The debrief transcript records her statement and moves on. Jeremy Hansen's debrief is more measured in tone. Hansen is by training and temperament an extremely precise and systematic thinker, and his description of the far-side transit focuses heavily on the procedural aspects of what the crew did during the blackout period. But at one point in his account, he mentions almost in passing that during a specific window of the transit, he attempted to make a note in his mission log and found himself unable to complete the thought he was trying to record. He described this as a momentary cognitive disruption, a brief period where his train of thought seemed to dissolve before he could capture it. He attributed this to the stress and novelty of the environment. He noted that it passed quickly, but he reported it because astronauts are trained to report everything, and that professional instinct is exactly why we have these details at all. Taken individually, Each of these accounts has a mundane explanation available. Wiseman's changed quality of silence could be a psychological response to the unprecedented isolation of the far side transit, a place no human had ever been in 50 years. Glover's luminescent regions could be any number of optical phenomena, from bioluminescent adjacent electrostatic discharges in the thin lunar exosphere to artifacts of the optical systems in the windows themselves. Koch's physical sensation could be a physiological response to the radiation environment, since high-energy particles interacting with the human body can produce sensory effects. Hansen's cognitive disruption could simply be fatigue and cognitive load in an extreme environment. All of these explanations are possible. All of them are reasonable. But here is what makes the Artemis II case unusual. Here is what separates it from a simple collection of individual stress responses and sensor glitches. All 4 crew members experienced anomalies during the same window of the far side transit. The sensor anomalies, the radiation spike, and the magnetometer fluctuations occurred during the same window. The crew's subjective experiences, when cross-referenced against the time-stamped sensor logs, align with that same window. And that window, that specific period during the far side transit when everything unusual seemed to happen simultaneously, corresponds geographically to the spacecraft's passage over a specific region of the lunar far side that has its own prior history of unusual observations. That region is the area surrounding and adjacent to the Daedalus crater. And to understand why Daedalus matters, we need to take a step back and look at the broader history of what we know, and more importantly what we don't know, about the lunar far side. Daedalus is a large impact crater near the center of the lunar far side. Its position near the moon's antipodal point makes it geographically significant because it is one of the most shielded locations from Earth-based radio interference on the entire moon. It has been seriously proposed multiple times as a potential site for a massive radio telescope installation, precisely because of this shielding. The crater is roughly 93 kilometers in diameter. It is ancient. It has been photographed from orbit by numerous missions. But Daedalus and the surrounding region have shown up in a recurring and curious way in the scientific literature associated with remote sensing of the lunar surface. There are papers, real peer-reviewed papers from institutions including research groups in China, Japan, and the United States that note unusual characteristics in the electromagnetic signatures of this region as measured from orbit. Some of these papers describe localized variations in the surface's thermal emission characteristics that are not fully explained by the surface composition data. Others note anomalies in radar backscatter that suggest subsurface structural irregularities at depths that are inconsistent with simple impact melt or volcanic activity. None of these papers makes any dramatic claim. They are scientific papers. They describe observations and note that further study is warranted. But the region keeps appearing in the literature as a place where the measurements don't quite add up. China's Chang'e program has contributed significantly to what we know about the far side. Chang'e 4, which landed in the von Karman crater within the South Pole Aitken Basin in January of 2019, was the first spacecraft to ever soft land on the lunar far side. The Yutu-2 rover that deployed from Chang'e 4 has been slowly exploring the far side surface and gathering data ever since. It holds the record for the longest operational duration of any lunar rover. The data from Yutu-2 has confirmed some of the subsurface anomalies that earlier orbital surveys hinted at. The rover's ground-penetrating radar found subsurface layering that is more complex than expected for the region, with features that some researchers have described as consistent with very ancient lava tube structures, though the evidence for that specific interpretation is still being debated. The Chang'e 6 mission, which executed the first-ever sample return from the lunar far side in 2024, retrieved samples from the Apollo crater within the South Pole Aitken Basin, and the analysis of those samples is still ongoing. But early indications from the analysis suggest a composition that has some characteristics researchers did not fully anticipate. The mantle material exposed in the South Pole Aitken Basin tells a story about the moon's interior that is still being reconciled with existing models. Some of the isotopic signatures in the returned samples are being described as offering new constraints on lunar formation models, which in scientific language means that the current models need adjustment to accommodate what was found. This is the broader context in which the Artemis II observations sit. The far side of the Moon is not well understood. It is the least explored major geological surface in the inner solar system accessible to us. Everything we think we know about it is a mosaic of incomplete data gathered from orbit, from a single Chinese lander operating in one location, and now from the first humans to actually fly over it in more than 50 years. And those humans reported things that don't fit cleanly into the existing framework. There's another dimension to this story that requires careful handling because it touches on an area where it's very easy to go off the rails into speculation that isn't grounded in anything real. But it would be dishonest to talk about the Artemis II anomalies without at least acknowledging the context of what we have and have not found in terms of organized structures on the lunar far side. For decades, since the first orbital photographs of the far side became available from Soviet probes in the late 1950s and then from NASA's lunar orbiter missions in the 1960s, there have been claims circulating about anomalous features in the surface imagery. Some of these claims are straightforwardly the result of pareidolia, the deeply human tendency to see meaningful shapes in random patterns. The human visual system is extraordinarily good at finding faces and geometric structures in noise. When you look at enough crater-pocked terrain under varying illumination conditions, you will find things that look like buildings or towers or tunnels, because your brain is built to find exactly those kinds of shapes. But not every anomalous feature claim is pareidolia. Some of them have been taken seriously enough by serious scientists to warrant a second look. The situation is complicated by the fact that the quality of imagery from the lunar far side has historically been much lower than for the near side, simply because it's harder to photograph. High-resolution imagery of the full far side is a relatively recent development, and it has mostly come from orbiting spacecraft whose primary mission was something other than imaging every square meter of the surface in forensic detail. What we can say with confidence is this: the subsurface structure of the lunar far side, based on what orbital measurements and the Yutu-2 rover have told us, is more complex and more irregular than a simple undifferentiated ancient crust. There are voids, there are density variations, there are thermal patterns that suggest the interior structure is not uniform in ways that impact formation and volcanic history alone cannot fully explain. Whether those structural irregularities have any significance beyond being the result of complex and ancient geological processes is not something we can determine from the data we currently have. What we can also say is that the Artemis II crew flew over this terrain for the first time in human history with the ability to make direct observational reports, and they reported things that were unusual. Let's look more carefully at Victor Glover's luminescence observation, because this one has a specific scientific context that makes it particularly interesting. The lunar surface is not entirely dark even in the absence of direct sunlight. The Moon has an extremely thin exosphere, a tenuous envelope of gas so thin it barely qualifies for the word. And within that exosphere, there are ongoing processes that can produce faint emission of light. Charged particles from the solar wind interact with the lunar surface and can release trapped gases, creating localized transient events that emit light at very low intensities. These are called transient lunar phenomena, and they have a long and controversial history. Transient lunar phenomena, or TLPs, have been reported by ground-based astronomers for centuries. Observers looking at the Moon through telescopes have reported brief flashes, glows, and color changes in specific regions. These reports are often dismissed as optical illusions or atmospheric effects in Earth's own atmosphere distorting the view, but they have also been cataloged in serious astronomical literature. NASA produced a catalog of reported TLPs in 1968 that lists hundreds of observations going back to the 1500s. The most frequently cited locations for TLP reports on the near side are the Aristarchus Plateau and the crater Alphonsus. Both of these locations are geologically interesting, associated with volcanic history and potential outgassing activity. The far side equivalent of these locations has never really been studied for TLPs, simply because you cannot observe the far side from Earth. You would need to be in orbit around the Moon or flying past it to see whether similar phenomena occur there. And that is exactly what the Artemis II crew was doing. Glover's description of diffuse luminescent regions in areas consistent with deep crater topology is, in the context of transient lunar phenomena research, not inherently extraordinary. Outgassing from deep crater floors, particularly in permanently shadowed regions where volatile compounds can accumulate over geological timescales, is a known potential mechanism for TLPs. The permanently shadowed regions of the lunar far side are actually more extensive than those of the near side due to the different topography. They are known to harbor water ice. They are chemically complex. If any location on the moon is going to produce occasional outgassing luminescence, the deep, permanently shadowed craters of the far side are a reasonable candidate. But the mission report's treatment of Glover's observation is curious. It is mentioned briefly in the section of the debrief transcript dealing with visual observations during the far side transit, and it is cross-referenced with a note indicating that the observation has been forwarded to the relevant science teams for assessment. That is all. No follow-up assessment is included in the mission report itself. No preliminary interpretation is offered. No timeline is given for when an assessment might be available. It is the written equivalent of a shrug. Something was seen, someone will look at it. Moving on. This is the pattern that runs through the entire official treatment of the Artemis II far-side anomalies. Each individual piece is acknowledged. Each is noted as being under review. None are explained, resolved, or discussed in any substantive way in the primary mission documentation. For a mission that was otherwise covered in exhaustive detail, with technical reports running to hundreds of pages on every system and subsystem of the Orion capsule, the far-side transit observations occupy a surprisingly slim and remarkably non-committal portion of the documentation. There is a principle that applies in investigative research called the dog that didn't bark. It comes from a Sherlock Holmes story where the significant clue is not something that happened, but something that conspicuously did not happen. The dog that should have barked when the intruder entered did not bark, and that silence is itself the evidence. In the case of the Artemis II mission report, the dog that didn't bark is the absence of any serious, extended, scientifically engaged discussion of what 4 astronauts reported experiencing and observing during the most unprecedented portion of their mission, their transit of the permanently dark far side of the moon. 4 experienced, highly trained, extremely credible human beings went somewhere no human had been in more than 50 years. Their spacecraft's instruments recorded anomalies during the transit. Each of the 4 crew members reported unusual subjective experiences during the same time window as those instrument anomalies. The region of the moon they were passing over at that time has an established prior history of unusual electromagnetic characteristics in the scientific literature, and the official mission report gives this entire episode several paragraphs, notes it is under further review, and then devotes 40 pages to the performance of the heat shield. That is the dog that didn't bark. Now, I want to be very precise about what I am and am not suggesting here, because this is the point in a story like this where it becomes very easy to drift into narrative territory that isn't supported by the evidence. What I am suggesting is that something anomalous happened during the Artemis II far-side transit. That is not speculation. That is documented. The sensor readings are documented. The crew reports are documented. The fact that the official mission report gives them minimal serious treatment is documented. What happened and what caused it is genuinely unknown. I am not suggesting a specific explanation. I am not suggesting that any particular extraordinary interpretation is correct. What I am suggesting is that the gap between what the crew reported and observed and what the official documentation engages with is real and notable and worth understanding. There are several categories of explanation available for the Artemis II anomalies, ranging from the completely mundane to the considerably more exotic, and it's worth walking through them honestly. The mundane explanations first, because they always deserve the first hearing. The radiation spike during the far-side transit could be associated with an undetected or mischaracterized minor solar event. Space weather monitoring is good but not perfect. There could have been a small enhancement in particle flux from the sun that fell below the threshold for official event classification, but was still detectable by Orion's sensitive instruments. The magnetometer fluctuations could be explained by the spacecraft passing over one of the lunar far side's known magnetic anomalies at an angle or trajectory that wasn't precisely modeled in advance, producing unexpected readings. The crew's subjective experiences could be the result of an unusual combination of sensory deprivation, elevated radiation exposure, and the profound psychological impact of genuine isolation from all human civilization for the first time in any of their lives. The Daedalus region connection could be partly coincidental and partly the result of confirmation bias in how subsequent analysis framed the correlation. All of these are plausible, none of them are confirmed, and the lack of any confident, detailed official explanation suggesting that any of these mundane interpretations is actually correct is itself part of what makes this story interesting. The less mundane explanations range from the scientifically speculative to the genuinely exotic. On the scientifically speculative end, there are serious proposals in the literature about the South Pole Aitken Basin and its environs representing the deepest excavation of the lunar interior accessible from the surface. The impact that created it would have punched through the entire lunar crust and excavated material from the upper mantle. This means that the geology of the far side in that broad region is fundamentally different from anywhere else on the Moon. The exposed mantle material has different electrical and magnetic properties from crustal rock. It could interact with the space environment in ways that haven't been fully characterized because no one has ever been close enough to study it in detail. An Orion capsule transiting this region at relatively low altitude in lunar orbital terms could be passing through a zone of unusual electromagnetic activity generated by the interaction between the mantle-derived surface materials and the solar wind, the magnetosphere of the Moon's localized anomalies, and the radiation environment of deep space. This would be scientifically extraordinary and enormously important, but not paranormal. It would be a natural planetary science phenomenon that we simply haven't had the chance to characterize before because we haven't been there with the right instruments in the right configuration. If this is the explanation, the Artemis II observations could be the opening data points of a completely new field of lunar science. That is exciting. That is exactly the kind of discovery that space exploration exists to make. On the more exotic end of the speculative spectrum, the permanently shadowed craters of the lunar far side have been in their current state for an extraordinarily long time. The deep cold of permanently shadowed regions, where temperatures can drop to among the lowest naturally occurring temperatures in the entire solar system, preserves chemical compounds with extreme fidelity. Water ice, complex organic molecules, and other volatiles can accumulate and persist in these environments over geological timescales. The chemistry of these regions is poorly understood. Whether that poorly understood chemistry could produce the kinds of faint luminescence and low-frequency physical effects that the Artemis II crew reported is an open scientific question, not a ridiculous one, an open one. And then there is the question of what lies beneath the surface in this region. The subsurface anomalies detected by orbital radar and confirmed in part by the U-22 rover suggest cavities and structural complexity below the surface. The largest potential lava tubes on the Moon would be on the far side, because the geology is older and the volcanic history is different. Some of these potential tubes, if they exist at the scale that some models suggest, would be enormous structures large enough to contain entire cities of human scale. Whether anything of significance exists within such structures is not something any available data can address. But the structures themselves may be real geological features, and a spacecraft transiting overhead at relatively low altitude might interact with the subsurface void spaces in electromagnetic ways that haven't been modeled. This is the responsible outer edge of what the available evidence can support. Not claims of definitive discovery, not dramatic conclusions. The recognition that we have very limited knowledge of a very complex environment, that trained observers reported things we cannot yet explain, and that the official documentation has not provided satisfactory explanations. There is a broader point here about how space agencies handle uncertainty, and it's worth making explicitly because it helps explain why stories like the Artemis II far-side anomalies get handled the way they do. NASA and other space agencies operate under intense public and political scrutiny. Every mission is expensive. Every mission is justified to taxpayers and to Congress on the basis of clear objectives with measurable outcomes. When missions return data that doesn't fit neatly into existing frameworks, the institutional pressure is to absorb that data quietly into ongoing research processes rather than to highlight it publicly in ways that could generate questions the agency isn't prepared to answer. This is not nefarious. It is actually a very rational institutional behavior. Scientists need time to analyze anomalous data carefully before making any public statements. Preliminary reports of anomalies can generate enormous amounts of speculative coverage that makes careful scientific investigation harder. The conservative approach is to say as little as possible publicly until you have something definitive to say. The problem with this conservative approach is that it creates information voids, and information voids get filled. People notice that something is being handled carefully and quietly. They notice the disproportion between the detail given to some aspects of a mission and the brevity given to others. They start asking questions. And in the absence of clear answers from official sources, they construct their own answers from whatever materials are available. This process is not always unreasonable. It's often how important stories get surfaced. What we know about the Artemis II far-side transit is that something happened that was anomalous, that the crew reported it professionally and in good faith, that the instruments corroborated aspects of their reports, and that the official documentation has not provided resolution. Everything beyond that is question. And questions, asked honestly and in good faith, are the right response to an honest and documented mystery. The moon is not a solved problem. This seems like a strange thing to say about the closest celestial body to Earth, the one that human beings have walked on, that we have studied from the ground for thousands of years, that we have sent dozens of spacecraft to orbit and land on and sample. But the moon is genuinely not a solved problem. We don't fully understand how it formed. The giant impact hypothesis, the idea that the moon was created when a Mars-sized body called Theia slammed into the early Earth, is the leading model, but it has significant problems reconciling the isotopic composition of lunar and Earth rocks that are still being worked through. We don't fully understand the history of the lunar magnetic field, which was once substantial and is now almost absent, a change that implies dramatic shifts in the moon's interior evolution. We don't understand the full extent or nature of the water resources in the permanently shadowed polar regions. We don't have a complete picture of what lies beneath the far side's ancient, cratered surface. We don't know why the crust of the far side is so much thicker than the near side, a pronounced asymmetry that existing formation models struggle to fully account for. The moon is the body in the solar system we have studied the most over the longest period of time with the most resources, and it is still full of fundamental open questions. That is humbling. It is also wonderful. It means that every mission to the moon, including Artemis II, and including the future Artemis missions that will actually put boots on the surface, has the genuine potential to change our understanding in significant ways. The Artemis program is not a nostalgia exercise. It's not just about going back because we went before. It's about going back with 50 years of accumulated knowledge and technology that allows us to ask new questions and gather new data in places and ways that were impossible in the Apollo era. The far side is the next frontier of lunar science. It is the place where some of the biggest remaining questions about the moon are most likely to find their answers. The South Pole Aitken Basin, with its exposed mantle material and its permanently shadowed ice-bearing craters, is one of the most scientifically valuable locations in the inner solar system. China knows this, which is why they landed there first. NASA knows this, which is why the Artemis landing site selections have increasingly focused on the South Polar region. The race to understand the far side is very much underway, and the Artemis II crew's observations, whatever their ultimate explanation turns out to be, are a part of that story. They are data points gathered by human beings in the most direct possible way. Direct sensory observation in the environment being studied is science at its most fundamental. Whatever Wiseman, Glover, Koch, and Hansen experienced during those minutes over the far side, it was real experience in a real environment. It deserves serious engagement, not a paragraph and a promise of future analysis. There is one more element of the Artemis II far side story that I haven't addressed yet, and it's perhaps the most speculative but also in some ways the most compelling. It concerns the timing and duration of the anomalous window. When you cross-reference the timestamps in the technical anomaly logs with the spacecraft's trajectory data, the anomalous window, the period during which the radiation spike occurred, the magnetometer fluctuations registered, and the crew members reported unusual subjective experiences, corresponds very precisely to the point in the far side transit where the spacecraft was at its closest approach to the lunar surface. Orion's trajectory on Artemis II was not a simple circular orbit. It was a complex path designed for the free return trajectory, and during a specific portion of that path, the spacecraft dipped to a lower altitude relative to the lunar surface than at any other point in the transit. This closest approach point happened to be directly over the Daedalus region. At that point, the spacecraft was at its maximum proximity to the anomalous electromagnetic characteristics of the far-side geology. If there is a causal relationship between the far-side surface environment and the anomalous readings and experiences, the trajectory data supports it. The anomalies were strongest when the spacecraft was closest to the region in question. They diminished as the spacecraft moved away. The time profile of the anomalous window matches the time profile of the spacecraft's approach to and departure from minimum altitude over that specific location. Correlation is not causation. Scientists say this constantly, and they say it for very good reasons. The fact that two things happen at the same time does not prove that one caused the other. But correlations are where investigations start. They are the initial signal that suggests a hypothesis worth testing. The correlation between the Artemis II anomalous window and the spacecraft's proximity to the geologically and electromagnetically unusual Daedalus region of the far side is not proof of anything. It is a lead worth following. It is a hypothesis worth designing a future mission to test. If the Artemis program proceeds as planned, future missions to the lunar surface will include surface operations in the South Polar region. Rovers will explore the permanently shadowed craters. Astronauts will walk on the surface and conduct experiments. The suite of instruments they will deploy and the data they will gather will be incomparably richer than anything gathered from orbit or from a flyby. Some of the questions raised by the Artemis II anomalies may find their answers in that future work. But some of them may require something that hasn't been done yet. A mission specifically designed to address the far side's anomalous characteristics. A long-duration lander or rover in the Daedalus region with sophisticated electromagnetic monitoring equipment. A seismic network deployed to probe the subsurface structure beneath the anomalous areas. A human expedition to the far side itself, not just a flyby but actual time on the surface, in the environment, with the ability to make sustained and detailed observations of the place that gave 4 astronauts experiences they are still struggling to fully explain. That mission doesn't exist yet. It's not on any announced schedule, but the case for it is stronger now than it was before Artemis II flew, because now we have something we didn't have before. We have a human report from the far side. We have a set of documented observations that raise specific and concrete questions about a specific and identifiable location. We have a target for investigation. We have a reason to go. The history of space exploration is a history of going somewhere for one reason and discovering something unexpected that gives you an entirely new reason to go back. Apollo 11 went to the moon to demonstrate that it could be done and to win a geopolitical race. It came back with rocks that rewrote our understanding of planetary formation. Viking 1 went to Mars to look for signs of life and came back with ambiguous chemistry results that are still being debated 50 years later. Cassini went to Saturn to study the rings and discovered that Enceladus was shooting liquid water into space, revealing an ocean world that is one of the most compelling candidates for extraterrestrial life in the solar system. Every time we send something into an environment we haven't fully characterized, we find things we didn't expect. That is the whole point. That is what makes it exploration rather than tourism. Artemis II was sent to prove that the hardware worked and that humans could survive the journey. It did that. It did exactly what it was asked to do. And in the process, over the lunar far side, in those silent minutes of radio blackout, it apparently did something else. It found a question. A specific, located, documented, corroborated question about a specific place on the most familiar, but still mysterious object in the night sky. What is happening in the electromagnetic environment of the Daedalus region of the lunar far side? What caused the sensor anomalies? What did the crew experience? What did Victor Glover see glowing in the dark craters below? We don't know. And not knowing is not a failure. Not knowing is an invitation. It's the universe saying, here is something you don't understand yet. Come closer. Bring better instruments. Stay longer. Look harder. The moon has been there for 4.5 billion years. It's been looking at us the entire time we've existed as a species. We've been looking back at